Hi, hello, ladies and gentlemen. Good evening, namaskaram, vanakkam. Welcome to the Pon Sudhya Sangam Zoom show on this Sunday, 24th of March 2024. This is our show number 114, and we propose to put up more shows on in this series. Please, Sridhar joining us from Chennai. We'll be talking about AI impact on environment. While we sit back, relax, and enjoy the show, our host is Mrs. Vijayalakshmi Nagarajan to walk us through the program. Vijayalakshmi Madam, kindly unmute and to go ahead.
Good evening, all of you.
Evening.
Welcome you all to our 114th episode of our Tapovan Sandhya Sangam program. As we all know, we have many eminent speakers and musicians in our Tapovan Sandhya Sangam group who have delivered lectures, shared their experiences in various fields of their expertise. Apart from that, we enjoyed few music concerts also through this platform. Today, it's going to be a pleasant surprise for us because our guest speaker, Mr. Sridhar from Chennai, is going to introduce us the latest technology, that is artificial intelligence, and its role in climatic change mitigation. Friends, today we are all experiencing the harmful impacts of climatic change on our Mother Earth. God has blessed us with all the five elements, such as earth, air, water, fire, and space, in abundance for our survival in the earth. God has given a special gift to human beings, that is our intelligence. We, the human beings, instead of using our natural intelligence to protect the nature, we misused the mother nature and spoiled it to a great extent for our selfish motives, and we neglected its sustainability. Recently, a latest modern tool, the AI technology, has been invented to mitigate the disastrous impacts of climatic change on our Earth. Today, Mr. Sridhar will deliver a lecture on this subject. Viewers, after the lecture, there will be an open session. Those who are interested can ask your questions to Mr. Sridhar. Now, let us move on to the next part of a session of our program. Now, let us begin our program with a prayer song. Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Parabrahma, Tasmai Sri Gurave Namaha. That is the prayer let us have today. And next one. Friends, now let us move on to the next session of our program, that is the guest introduction. May I request Mr. Subramanian K to introduce our guest speaker, Mr. Sridhar, to our audience.
Thank you, Vijayalakshmi Madam. In fact, Sridhar is not new to us. He has been with us earlier also, and he has given us good lectures regarding the environment issue. And he has 37 years of experience in areas of pharma product promotion, medical product marketing strategy formulation and implementation. He is an expert in interface between company's product promotion team and medical practitioners. He has been imparting field and classroom training and mentoring sales teams. There have been quite a few awards and recognitions for his efforts. He has been awarded Star Performer at various international company events between 2003 and 2012. He has been awarded User Award for Salesforce Automation Systems in 2005. He was selected to give field training to new recruits. His hobbies includes reading, interest in demographic studies, sustainable living, interaction with international agencies that promote sustainable living, giving lectures on environmental issues at schools, colleges, civic awareness groups, and public sector organizations. And that's quite an impressive profile of Mr. Sridhar we have over here. Well, back to you, Vijayalakshmi Madam.
Thank you, Subramanian, for the wonderful introduction of our chief guest, Mr. Sridhar. Now it's time for our guest speaker, Mr. Sridhar, to address the audience. Let me hand over the stage to Mr. Sridhar. Sir, we are all anxiously waiting to listen to your speech.
Thank you. Am I audible to all of you?
Yes, very much.
Very good. Good evening, sirs. Thanks for that very warm introduction, Mr. Subramaniam. In fact, I had the privilege of giving 2 lectures to the type 1 group, one on diabetes and one on global warming. This is going to be on the role of applying artificial intelligence in climate change mitigation. So we start off right away. I'll share the screen, sir. See if it's available. Now is it screen is open to all of you?
Yes, yes.
Very good. Now we start off right away. So we are going to talk about the role of artificial intelligence in climate change mitigation. In fact, as a hindsight, we will realize that both climate change and artificial intelligence share the same platform. They have many things in common. One thing is, it is going to affect all of us, whether we like it or not. Artificial intelligence and climate change is going to affect all of us. In all our activities, it is going to come. It's a matter of time. Artificial intelligence is very new. Climate change has got a short history, but a long future. Okay. Secondly, both are created by humans, right? I'm talking about climate change, anthropogenic climate change. That is climate change that has been where humans have been responsible for it. Natural cycles of climate change is always there. That induced by humans is called anthropogenic climate change. So both artificial intelligence and climate change, humans have been responsible for introducing that. And both are disruptive technologies. Okay? It is going to disrupt our lives. So how we learn to use artificial intelligence and other emerging technologies to mitigate the bad effects of climate change is what we are going to see now. And of course, the most interesting part is both are disruptive technologies, both are human induced, and both can play havoc if not properly used. The most interesting thing is climate change is going to help us see artificial intelligence is going to help us see what climate change can do and how we can mitigate its march. Now, how I arrange the slides is, see, I have to be fair for both climate change and artificial intelligence. So the first few slides will tell us what climate change, anthropogenic, human-induced climate change is all about. And the next set of slides will talk about how artificial intelligence might be useful in mitigating climate change. Now, the first slide, right? We need to know about, am I audible, sir, for everybody?
Yeah, yes.
We need to know that the world population, this is how we have grown over a number of years. It was 500 million in 1650 AD. The next doubling of population took place in 150 years. The second doubling of population between 1 billion to 2 billion occurred in 130 years. The third doubling of population took just a matter of 45 years. Right. And the fourth doubling of population took a matter of nearly 60 years. And the next doubling of population will not take place. It's good for all of us because world over, scientists, governments are working on limiting family size and see how human demographic stability is maintained. Right. This is yet another slide which shows how we have grown over a period of years. This is from US Census Bureau International. See, from 1950, we are hardly 2.5 billion. Now we are close to 8 billion in 2025. And very likely, the world population might stabilize around 9.5 billion people. And most of the growth in the world population will be taking place in developing countries. And what is all this about? The growth in number of households and shift in consumption patterns. What happens is As a young population keeps on growing, more and more people are added to it, a reproductive age. What happens is they need factories, they need schools, they need hospitals, they need roads, they need bridges, they need buildings, they need electricity, white goods. So what happens? The consumption keeps on going up. So how are you going to put up with it? So the shift in consumption patterns happen. And all this ends up in onslaught on resources. For all we know, the world economy can be equal to energy. It's the energy which props up the world economy and keeps it running. So whatever human activities in agriculture, agriculture is a good user of energy. Agriculture, industry, transportation, housing, everything uses energy. So because the simple this growth in human numbers and growth, especially in developing countries like India and China, we find there's an onslaught on resources, fossil fuels, land, air, and water, and also our minds. Now, just an extension of that, worldwide, this is how the energy consumption pattern has been. Right from the year 1800, post-industrial revolution, to the year 1900, the growth in energy consumption was not very appreciable. But from the year 1900, when the world population also started growing, you will see that the energy demand has grown up. You will also realize that gas, oil, and coal make up the bulk of energy resources, close to 75%. It might differ from country to country. By and large, fossil fuels, even today, also in the past, they have been providing energy which is needed to run the world economy. So we can safely assume, we can safely say that the past 2 centuries can be described as a hydrocarbon man. So we have been depending on hydrocarbons, whether it is for transportation, for energy for household, factories. These are all the hydrocarbons, coal, oil, and gas, which have provided all the energy we want. It's a very seminal moment. Today, it's a very seminal moment. Not today, the years are going to come. Because renewable energy, it's finding its rightful place, and it has to. That's going to grow in vast numbers. The whole presentation of mine is going to be on how renewable energy can be integrated into the energy mix. Right. This is a very important slide. Just remember the first part of it. As I told you, fossil fuels are extremely important in providing us energy. Every ton of gold that is burned releases 2 tons of carbon dioxide. That is carbon plus oxygen. The weight goes up. Carbon dioxide is a greenhouse gas. That is, though the atmospheric concentration of carbon dioxide is negligible, still it can play havoc if it goes beyond a certain point. So now, all of us know that the level of greenhouse gases, primarily carbon dioxide, have been going up in our atmosphere due to various reasons, primarily because of fossil fuel usage. So every ton of coal burned releases 2 tons of carbon dioxide, which means that coal is a primary form of energy. It's a dirty form of energy, but it's simply very good and very cheap. So world over, especially in a country like India, China, coal is a very important contributor to our energy resource. Okay, forget all these things. Acid, okay, forget all these things. Now, the usage of coal that releases greenhouse gases is responsible for global warming. It's a good slide. This is from a very famous observatory in the United States called Mauna Loa Observatory from the Scripps Institution of Oceanography. Now, from the year 1960s, much before that, when records are in place, you will see the carbon dioxide. Carbon dioxide is measured in parts per million. If you take 1,000 parts of air and divide it, you will find carbon dioxide is only 330 parts per million. Very insignificant, but still can wreak havoc. So the carbon dioxide content has been going up, and up, straight up. Now we are close to 435 parts per million. In 1960, it was 320. Roughly, we shot up by nearly 40%. I don't know, should be 40%, 50%, something like that. So in a matter of 65 years. Okay. This is a very good slide. This is from the World Watch Institute. Incidentally, World Watch Institute was the first international institute with which I had a mail collection. They used to send me very good literatures on human demography, on environment. So a lot of slides. It's a very good institute. So here it's a lean. It shows that the relationship between carbon dioxide buildup and growth in average temperature of the Earth. So it's a linear relationship. As the carbon dioxide content in the air moves from 300 parts per million to more than 400 parts per million, you will find that the average temperature of the Earth keeps on going. The average temperature of the Earth is nearly 14 degrees centigrade. It has moved up to 14.8. Now it is more than 15. 1 degree centigrade in a matter of nearly a decade, in 100 years. Okay. So, what can we say? Double trouble. We can say it is double trouble or partners in crime. Both the growth in carbon dioxide content and also the increase in world temperature, partners in crime. And who's the originator behind this? Ourselves. So how we are going to behave in the future? How we are going to lessen the impacts of climate change are extremely important, especially with respect to energy use. World economies today is directly dependent on energy. Okay. So just few more slides on carbon dioxide. This is a very good slide. See, from 1880 to the year 2000 and beyond, the world temperature has been going up. From 60 to between 1950 till today, the world economy has grown up by nearly 15 times on 1950s value. 15 times. Directly, the world energy, more of energy is needed for all the growth of world economy. And temperature is shot up. Not only that, the annual 5-year mean, see, some years the annual world global average temperature might go up. Some years may drop down. But the mean average of 5 years, that also shows going up, the thick line. So definitely, world temperature has been going up. We are not connecting the dots. Why it is growing up? What are the reasons? There are plenty of reasons. Okay. And the last slide on temperature. This is again global temperature. It was relatively normal, average, steady until the year 1950. When the economies of the world over, after post-World War, the economy started building up, you will see the increase in world. It's consistent heights. Okay. What does it all come down to? The increase in world temperature, the increase in global warming has got multifarious effects. One of it is it can cause irreversible damage to agricultural systems. We really don't know how our agricultural systems are going to behave. The oceans are warming up. There is increased intensity of cyclones, increased number of cyclones. The ocean temperature is going up. We simply don't know how our oceans are going to behave. We'll see that later. How our oceans are going to behave. How much of the world's food comes from our oceans. How the fishes are going to behave. What's going to happen to them? We really don't know. And the world's oceans also regulate world temperature. And the world's oceans are carbon sinks. Higher the carbon dioxide content goes up, the oceans absorb carbon sinks, waves carbon sinks. And the oceans are becoming acidic. More of carbon dioxide going to the oceans are becoming more acidic. We really don't know. So the buildup of carbon dioxide in the atmosphere is perhaps the world's biggest scientific experiment, knowingly or unknowingly, we are committed to. We really don't know the effects. We are only postulating. Now, one of the biggest threats of worldwide growth in carbon dioxide content and world temperature is the rise in sea levels. Even agriculture, we can do something about it. Drought we can do. The spread of deserts we can stop. anything we can do. But how do we stop rise in global sea levels? The world sea levels has grown in a period of 100 years, 120 years. It has gone up by 19 centimeters. Okay, 19 centimeters it has grown so far after the Industrial Revolution. And today, research shows every year the sea average, global mean average sea level is going up by 4 millimeters a year. Right? This is a beautiful slide. This tells us how the ocean, it's very important. Warming of oceans, rise in sea level is the biggest threat mankind is ever going to face. Imagine 40% of the world's population lives near to coastlines, or at least 50 kilometers from the coastline. Much of the world's fertile regions, crop growing regions are near coastlines. Imagine a situation when the coastlines get flooded, sea water ingress. What will happen? We'll all become environmental refugees. This might not happen now, but happen 50 years later. This is a very serious thing. This is a beautiful slide which shows how melting glaciers, land water storage, melting Greenland ice sheet, thermal expansion of water, all these things are responsible for sea level rise. This is a beautiful slide which tells us now, look at this. It's dark one, dark. Thermal expansion of water between 0 and 2000 meters, 2 kilometers. See, the sea level goes in depth as we go away from the shore. Nearer to the shore, you will find the water expands bigger, higher. So definitely there's going to be the surgeon types, the surgeon waves are going to be there in future because the expansion in water is higher between 0 and 2000 meters. Of course, melting glaciers, land water storage, everything is going to increase. This is very important. This slide tells us using all artificial intelligence has been in place to assess sea level rise, to assess satellite images. Okay, we will come to that later. What I have talked now, artificial intelligence has found a place in assessing all this. You will find the projected sea level could be anywhere between 0.3 meters to 1.2 meters until the year 2000 and beyond. And if we don't stick to the guidelines postulated, if we end up at 3 meters, 2.4 meters, we never know what's going to happen. This is yet another good slide, which tells us about this is the final slide with respect to carbon dioxide buildup and what deleterious things can happen. Now, if we can keep the Earth's temperature below 1.5 degrees centigrade when compared to the pre-industrial average, it is good enough. Okay. Now, if there are some, the COP28 meetings keep happening where countries pledge, okay, we will control our emissions, we will do this, we will do that. So if we stick to the Paris pledges which countries have made, then the world temperature could increase between 2.5 to 2.8 degrees centigrade by the end of another 100 years, 75 years to be precise. If current policies are followed, it can end up with an increase to 3.3. If nothing is followed, we run as we are in the treadmill, the fast treadmill of our economy, it can end up anywhere between 4.1 to 4. These are all projections. Artificial intelligence are involved in such predictions in climate models. So these are all the wedges. Usually, our climate can increase, the temperature can increase between 1.5 degrees centigrade to nearly 5 degrees centigrade. When it is 5 degrees centigrade, I think half of humanity will vanish. Nothing like that is going to happen because technology is there, and that is what, and how we behave, how we are going to adopt lifestyles is very important. That's a separate thing. So all these put together is global warming. The rise in human temperature is global warming. Right. Now we come to the second part. artificial intelligence and what and how it can be used, it was used, and how it can mitigate climate change. Now, artificial intelligence has been, I'm not a coder. I'm not a technical expert in artificial intelligence. I have done courses on artificial intelligence and climate change, artificial intelligence on forestry, artificial intelligence and health policies. Okay, I don't remember the correct wordings. Okay. Now, artificial intelligence has been around from 1950 onwards, but the real growth in the application of artificial intelligence has been from the year 2020, 2020. Chat GPT, but all these are language models. Okay. The growth in artificial intelligence is now possible because vast amount of data is available. Data is available from sensors. Sensors can be placed everywhere, in the field, in the oceans, in the mountains, in the buildings, in our houses, inside our houses. Anywhere you want, you can have sensors. And the sensors will pull in the data. That is how every time we use a mobile phone, we buy something, we make a payment, the data goes. Right? Brilliant amounts of data is connected. We don't know what to do with the data. Too much of data is also a problem. Okay, I told you, satellite imagery. Data from satellite images come. No, okay. And the most important, internet. Internet throws out a voluminous amount of data. Internet availability and its adoption. Everybody uses the internet. So does artificial intelligence. Faster computing power, supercomputers. If artificial intelligence on a wider scale application is just not possible without faster computing power. And day by day, faster computing power is possible. It is coming. Open software storage. Why use artificial intelligence? Sometimes I wonder, many times, most of our inventions may not be needed or the right kind of inventions did not come. For example, take the last century. We invented the internet, we invented the nuclear facilities, we invented, we sent the man to the moon, we mining, in everything, fantastic pace of inventions were there. But it looks ridiculous. Nobody thought of putting a wheel to the suitcase. Until the year, I think 2002 or 2003, we were carrying our suitcases by hand. Nobody put a wheel to the suitcase, which is much needed. It looks ridiculous. Okay. But today, the arrival of artificial intelligence, I feel, is necessary. Why use artificial intelligence? Climate change mitigation has to happen in a very short time. Artificial intelligence is very new, hardly 10 years, the growth. But climate change, the buildup in carbon dioxide has been happening post-industrial revolution. That is also very short, 200 years. So they say climate change, buildup of carbon dioxide has got a short history, but a long future. Okay? So artificial intelligence enables cross-functional areas. For example, it can be, I told you, it can be used in factories everywhere, and data can be pulled so that for the benefit of how it can be used. Cross-functional areas data will come, and it can be used to reduce energy usage, reduce emissions, so on, reduce consumption, so on. So what is artificial intelligence? I'll come to that, how it works, the knowledge to the extent I know. Artificial intelligence helps distill raw, unstructured data for actionable information, right? Artificial intelligence is all about data. It will die without data. We have to keep on training the machine algorithms with data. We have to label the data, as far as I know. We have to label the data. Most of the improvements in artificial intelligence is narrow AI, they call it, which means it can do only specific tasks. As of today, you have to feed data. You have to show 1 million images. So what happens? It keeps on assimilating and it finds patterns. It finds patterns. This is a brief, pictorial representation of what artificial intelligence is all about, as much as I can. There's input. This is the data layer, input layer. You have to keep on feeding inputs. It's much structured like the human neurons. The data keeps going inside, and multiple layers are there. Each and every layer has got a specific function. It's got a specific function. But what happens is, as soon as data is being fed, this talks with the hidden layers. There are hidden multiple layers. Information goes through all the layers, I believe. There's a cross-talking which happens. Looks fabulous. Cross-talking happens. And weightage, slightly technical. As we keep feeding data, the machine learns by itself. How it learns? It learns by giving weightages. Weightages, okay. And finally, the output layer is there. According to the weightage which the machine gives, the output layer. For example, a suitable analogy would be, suppose the final examinations are dependent on monthly tests. The teacher gives a monthly test on all subjects and attaches a weightage to economics, to commerce, to mathematics. So how the student performs every month, every class test, there's a weightage. And finally, whether the students pass or do not pass depends on the weightage given. So that is how. Lot of information has to be fed into the input layers. Finally, and scientists are skeptical. I really don't know how the machine learns. And finally, the algorithm gives out the patterns. It gives us artificial intelligence. Now, willpower. I told you the whole world economy is only about energy, energy, and energy. Okay, very important. You all know about net zero. That is, the emissions of the world economy should touch net zero, which means we spew emissions, carbon dioxide into the air, and the oceans absorb it, the forests absorb the half of the emissions which go up. By 2050, most of the major economies have that we will control our emissions to zero. Whatever that goes out, we'll have forests, we'll have oceans, we'll have water bodies, we'll have support. India has said it's a developing country. We are not technologically advanced as much as you are. So we want 20, and we are dependent on coal. We want 20 years more. By 2070, we will achieve net zero. So does China. Now, how are we going to achieve this? Renewables are believed like solar, like wind, and nuclear. They are supposed to play a very big part. In fact, Prime Minister Modi has assured by the year 2030, that is nearly 6 years away, 50% of India's electricity production is going to be non-renewable. I'm sorry, renewable. That includes nuclear, renewables. Okay, so wind, solar farms, they're all going to play a big part. This is where artificial intelligence is going to be very important. See, this is wind power forecasting using machine learning, using neural networks. See, data has been fed to machine systems, and it has predicted what the wind speed is going to be, depending on the data that has been fed, the past data. It in meters per second. It is predicted. Okay, real value is shown in blue dots. The predicted value is in dark. It more or less shows a coincidence. It is closer. The blue dots are closer. So as the wind speed keeps on moving up, at one point of time, the power output is going to stagnate. These are all artificial intelligence shown. This is the next one here, predicted power to real power values. More or less it coincides. This is very important. How it does this? Neural networks, machine learning. See, the past data about wind speed, the past data about wind and the average temperature, the past data about wing angles. All this has to be fed. Millions of data has to be fed. These are all called slightly technical. Don't worry, I am as good as you are. So these are called hidden layers, which means all this temperature, angle, humidity, wind speed, the past data has been fed. Okay, the computational layers will tell you what the wind speed is going to be in another 5 days time. In another 3 days time, what is the wind speed is going to be. So much so for solar. If you feed all the data into a machine learning, the artificial intelligence using its multiple layers computational things, it will say the sun is the output from your solar farms is going to be only this much, or is going to be this much in another 5 days. Okay. Many times in newspapers you would have found that a lot of wind energy is being generated in Tamil Nadu. The leading players. Tamil Nadu is a leading player in wind generated electricity. Many times, nearly during periods of good wind, 35% of Tamil Nadu's wind energy, that 35% of electricity consumption of Tamil Nadu comes from wind power. Phenomenal. Many times, unfortunately, due to grid problems, pricing problems, the generated wind power is not being evacuated. It's not being evacuated. Windmills have to be shut down. It's not evacuated. Money is not being made. Okay. Artificial networks will tell us this is going to be the wind power in another 5 days time. Okay. Now, so for solar, so for wind power, which are all very important renewables. Renewables is which is perpetual. It is very important. Wind power and solar power are intermittent forms of energy. When coal is used in a thermal power plant, you can predict so many kilograms of coal will produce so much of electricity. So much kilograms of nuclear power, grams of nuclear power rods are used, so much of electricity. With wind and solar, they're intermittent. One cloud cover, the solar electricity will fall. Suddenly a burst of wind, the wind power will go. Suddenly the wind stops blowing, and wind power is, the wind blows only 30 to 40% of the times. Enough to produce electricity. So, artificial intelligence and grid, as I told you, predicting electricity demand, intermittency of renewables, preventing blackouts, smart grids. Everywhere artificial intelligence is being used. It's a predictive tool, right? As far as I know. This is from DeepMind. This is a Google-sponsored company based in UK. DeepMind system predicts wind power output 36 years ahead, 36 hours ahead, right? You see, predicted value, which is in blue dark, and actual value, which is in gray. You find if it is going to be the next day or the next day, the values are closer. As as you want the prediction for more number of days, there is some disparity. There is some closeness also. This is very important because utility companies like our own Tamil Nadu Electricity Distribution Company, they depend on various sources of energy, the inputs. Okay, world over, except for few countries, world over, all the countries will have to depend on various forms of energy for many years to come. Coal, oil, gas, wind, solar, nuclear, wave energy, all while fantastic research is going on. Now, this is where artificial intelligence plays a very important role. See, it tells the grid operators what is going to be the wind power, wind generated electricity, solar generated electricity. It is going to tell the operators. So better be prepared. Or next Saturday, the wind power and electricity is going to come down. Jack up your coal power. So this will prevent blackouts. As it is, there are no blackouts. But suppose it happens, it can be very bad. To prevent blackouts, smarter grids are possible because of artificial intelligence. Right. Sir, am I okay till now?
Yeah, fine.
Good. Okay. And this is yet another beautiful slide. See, artificial intelligence is as good as the data you feed. It has, and in weather forecasting, voluminous data is there. Voluminous data. No single supercomputer can do it. Artificial intelligence is very important in predicting weather forecasts. See, this is climate modeling today. Projected surface temperature change from 2020 to 2016. I don't know the veracity of these slides. I print it up. Okay. Now, the temperature can hover anywhere from 3 to 1.5. That depends on the cloud cover. More the cloud cover, the surface temperature is low, I believe. More the cloud cover, less the cloud cover, the surface temperature go up. Simply because it is a known scientific fact that the presence of clouds reflects the insolent, the solar radiation coming. When you have lot of clouds, it reflects a lot of solar radiation, brings down the average temperature. And there are reasons to believe, afforestation, growth in number of trees will hold on to the clouds. Cloud formation is possible because of ample tree cover. There is research to show that. So, back to good old days, more of afforestation. Okay. I was talking about this and weather forecasting. The usage of artificial intelligence today, voluminous data, predicts tropical cyclones with 90% accuracy. But tropical cyclones can be very, and due to climate change, the intensity of the cyclones and the number of cyclones has been going up. So we need to evacuate people. Contingency measures should be in place. So artificial intelligence is already in use. It is going to be in further use, in magnified use in weather forecast. Identifying atmospheric rivers. I believe there are atmospheric rivers. You call it a cloud burst. Suddenly, you will find they call episodic rainfall. 2015, Chennai city witnessed nearly 50 centimeters of rainfall in a matter of 48 hours. Never before in the history it has happened. Extreme precipitation. They call this atmospheric rivers. Rivers, I'm sorry, wrong spelling. Rivers. RAVERS, wrong spelling. Artificial intelligence with using satellite imagery. If you feed in a lot of data, it can say atmospheric rivers are here. It is going to strike us. Something like that. It can predict. Faster approximate. See, climate change, weather forecasting, you've got a lot of models. This has to be pulled together and data has to come out. So faster approximations of plenty of models improves the quality of models. A lot of models are there. The usage of artificial intelligence, machine learning is going to improve the models, but all is data driven. We have to label the data. And they say general artificial intelligence will pick up data from everywhere. It will pick up data from Google. It will pick up data from YouTube. Suppose you are going to upload my talk today in YouTube, which I believe you will. This data will also be picked up by artificial intelligence. So data keeps picking up, identify patterns, and gives out an output. Okay. The last 3 or 4 slides. Other deployments of artificial intelligence. Artificial intelligence in agriculture. Now, it's a known fact that groundnut farmers in India, their output has gone up by nearly 30 to 40% because of use of artificial intelligence. Sensors can be placed all over the ground, the farming land, and it will tell us what is the humidity, what is the fertilizer level there, what is the water level there, what is the ambient temperature, what is the level of various other nutrients in the soil, whether topsoil is maintained. It will give data. Millions of sensors worldwide. And this will all go into a central server. The artificial intelligence will be placed. And every farmer has got a mobile phone. At least they have got a computer center and officials are at work. Tell the farmer, don't sow your groundnuts now. sow your groundnuts slow. You have to water your fields only this much. You add this kind of a fertilizer. This is in place now. In fact, I had written an article called BHU Vision initiated by Prime Minister Modi. BHU Vision, it talks about how artificial intelligence can be used. You can go to the Google and see how artificial intelligence can be used in agriculture. All these sensors are in place and meters have been given to the farmers or somebody can use it. The data goes to central server. And before sowing, the farmer measures on it. Never before the history it has happened. He goes into that and says, no, today I'm not going to put groundnut. Today I'm going to put only millets this season because the conditions are right for millets. This was done by farmers, but artificial intelligence uses enormous amounts of data. We need to believe in that also. Artificial intelligence and materials economy. As I told you, it's all materials. So likewise, sensors can be placed in extraction of materials. The process, how material process can be more energy efficient, how they can reduce emissions, how extractions can be better, should they extract at all, how materials can be extracted from the ocean floor, where you can find materials in the ocean floor. Many things are possible. Artificial intelligence forest fires can be predicted. Artificial sensors can be placed all over the forest. And an analysis after the forest fire, they have shown these are the kind of trees which will not withstand this high temperature. You have to reforest with a different kind of tree models, which will withstand forest fire. All this has been done. Okay, satellite and vast forest, talking about millions of square kilometers. It will tell you at what level forest fires happen, which trees are susceptible to forest fires, which trees have withstood that, what can be done about it. Enormous data is AI in artificial intelligence is managing soil erosion. Worldwide, soils are getting eroded. India has lost 50% of its fertile soil. What do? We need to grow our vegetables. Earlier, in slash and burn agriculture, long time back, agriculture பண்ணுவாங்க. When the fertility goes down, what they'll simply they'll go to another place. In another 10 years, this place will regenerate. It will become fertile. Come back here. It's not possible though. Multiple crop rotation because we have to feed a huge population. Soil erosion is rampant. Soil erosion is rampant because of poor soil maintenance. So artificial intelligence is being used, will be used in assessing soil erosion. It can stop desertification. Worldwide, deserts are growing by nearly 5,500 square kilometers every year. Artificial intelligence using plentiful sensors, satellite imagery can show desertification is happening here. We need to afforest that place. The Sahel region in Africa is being done. Artificial intelligence in supply chain. This is a vast area. My knowledge is extremely limited on this. Artificial intelligence, it can, the various forms of transportation, it can optimize. In Switzerland, you go to the YouTube and see why Swiss trains are very good transportation systems. Because they have integrated. I have not been to Switzerland. I would like to go. I need not go. YouTube tells everything. Okay. They have integrated the transportation system so well. It's a small country, but still a mountainous country. Still, laying railways is an arduous task. It's not cheap. They have integrated the system so well. Perhaps using artificial intelligence, trains run on time. Moving from one place to another, even if you have to switch trains, doesn't take much time. It goes by the clock. Such things are possible. Transportation is a very, and believe me, agriculture, the materials economy, all this uses up a lot of energy. Once artificial intelligence is in place, used properly, you can produce the same amount of materials. You can reduce the amount of materials produced. You can improve agriculture productivity using lower amounts of water, lesser amounts of water, lesser amounts of material. All this uses energy. Energy is the fulcrum around which the world economy grows. Right. So the last 3 slides. So what should be our response? Switch to energy efficient appliances. Right. The easiest thing each one of us can do is switch off lights and fans wherever not used. After all buildings are furnaces. Switch off lights and fans. See, one LED tube light is, there are 2 tube lights where one is enough. Why? Okay, today I'm talking, I need to be bright. I believe as much as my lecture should. So, burning furnaces, every building is a furnace. You find malls. Any given point of time, there are only 10 people in malls. How much of air conditioners? How much of electricity? I don't want malls, I don't like malls. Okay, just for this reason. Okay, judicious use of electricity. Okay, more the usage of electricity, you need to connect the dots. The more of electricity use, the more of emissions, more of carbon dioxide, more of climate change. They say, unfortunately, I have not put the slides. Food wastage is a very big contributor to emissions, because when you waste a morsel of food, don't think you and I are wasting a morsel of food. Look at the amount of fertilizers that have gone into production, amount of water, amount of labor. All this is energy. They say if all the food waste were to be grouped together, okay, it is the world's third largest emitter of carbon dioxide. Food waste, I'm not talking about food consumption. So if we can reduce food waste, wherever, supermarket, household, let's cook less, eat optimally. And of course, they say that when we move to a more plant-based diet, the energy costs come down. But that's a very touchy subject. Let's not go into that. Recycling of materials. India is a world leader. But we need to better it. Artificial intelligence can be in place. How materials can be recycled? Because it takes more energy to produce material from a virgin gold. So if you can recycle, reduce, reconsider, all the more better. And why should we? Energy efficiency could cut short emissions by half. Source segregation, it's a different topic. Ecological thresholds are not apparent to us. For example, desertification. Suppose water table coming down. Suddenly the prices of foodstuffs go up. Suddenly electricity demand goes up. Suddenly something happens. It keeps on happening. We don't connect the dots. The dots are connected in Scandinavian countries. They see the effects of global warming in a much larger impactful scale than what's happening. So ecological thresholds are not very apparent. And firmly, I believe we have seen the agricultural revolution. We have seen the industrial revolution. We have seen the communications revolution. And we need to see the conservation revolution. We need to see it. This is a beautiful slide I picked up from the founder of World Watch Institute, Lester R. Brown. We have not inherited this earth from our forefathers, but have borrowed it from our sheep. That completes my talk. Thank you, sir. I thank you, the organizers, for giving me this wonderful lecture, and I hope I have done justice to it. Thank you, sir. I'm ready for questions. Yes, sir. Any question? Why at all use AI?
Madam, சொல்லுங்க விஜயலட்சுமி madam.
Um, Thank you, sir, for giving so many information about artificial intelligence. Okay, and sir, before listening to your speech, I had some bad opinion about it because of that deep fake and all these things. You know, it has all hyped in the media channels and all these things. I was so much worried about it. After hearing your lecture, I really feel very comfortable and good.
On
I
the
think
on the
every-
contrary,
yes,
ma'am, everybody is worried about artificial intelligence. How many
yes,
jobs will go? What will happen to news, fake media?
correct.
Everybody is worried. But I believe legislation should be in place. It will be in place. We can't arrest the progress of science. How it is used is very important.
Every coin has two sides like that, no? It is a boon as well as a curse, but
Yes.
how we are going to use it, it depends
Absolutely.
upon it.
Yes.
Okay, thank you so much, sir, for this
Thank you.
nice lecture
Thank
and
you.
very informative.
Thank
Thanks a lot. And I request our audience, if anybody has any queries, to ask Mr. Sridhar. Is there anyone?
Well, it has been a very thought-provoking lecture, as always, Mr. Sridhar sir. It's a very tough subject. It's not so easy to grasp everything in one go. One has to listen to the recording also. But the underlying point over here is we need to leave a better place for the new generation to come.
Absolutely, sir.
We cannot spoil and go away just like that because we have a responsibility of giving it safe for them. We have lived safe for all these years. We want the future generation also to live as safe as we were. So we need to live it as a better place. And that's what our effort should be. And in whatever possible way we can do it, we should try to do it. Thank you so much, Sridhar sir. Thank you very much for your valuable time. Thank you, Vijayashri Madam, for wonderful navigation through the program. Thank you, ladies and gentlemen, for joining the show. The recording of this show will be uploaded on YouTube sometime tomorrow. Link will be provided, and share the link as widely as possible so that larger section of people could get to know what has been discussed.
Thank you, sir.
And that's a wrap up, Malabas, over here. Until we meet next, is wishing you all goodbye, good night, and
Thank you. Thank you for giving me this opportunity.